Hello, I am Pia, and this is a crash course on organic chemistry. In this crash course, we will discuss distinct compounds in organic chemistry, such as ethers, carboxylic acids, and esters. Before that, let us know what are the different names and forms there is in organic chemistry.
Let's discuss about forms. Skeletal. This is drawn with lines in zigzag direction, and each corner of a line represents a carbon. Expanded. This form is drawn with the initial of the respective molecule, such as carbons and their hydrogens, attached with lines. Condensed. This is done by identifying each molecule and its attachment, then add in the number of attachments present. Now for naming. Common name. It identifies first what type of attachment is present, then counts the number of carbons of the mother chain. IUPAC. It specifies first the location of the attachment, then names the mother chain.
After discussing the different chemical names and forms there is in organic chemistry, you would wonder, why do we have to learn this? Simply because organic compounds contain a carbon, and this is important because every living organism is made up of carbon. Understanding organic compounds help us define our biological structure and for others too. This contributes to knowledge of what is our biological makeup and how we function.
Ethers, carboxylic acids, esters. Ethers. This contains an oxygen atom which is bonded by two carbons in a single bond. This may also be attached with an alkyl, cycloalkyl, or aryl group. This is present in anesthetic products such as shots or laughing gas. How to name this? Let's start in naming the skeletal form of ethers. The prefix of ethers is oxy after the attachment in IUPAC and ends with ethers with common name. In IUPAC, we identify first if there is an attachment. If so, locate in which carbon of the mother chain can it be found. The attachment is found at the fourth carbon, so we name it 4. We then count the number of carbons in the attachment. Because there are 4 carbons, the prefix is but. Further, we count the number of carbons of the mother chain. And identify last if there are any bonds. There is a double bond found at the second carbon, and because it is a double bond, the prefix for that is -ene. We name it hex because there are 6 carbons in the mother chain. Altogether, it is 4-butoxy-hex-2-ene. The common name of this skeletal form is butyl because there are 4 carbons of the attachment, hexyl because that is 6 carbons of the mother chain, and ester. Now let's try expanded form. The IUPAC of this form is methoxyethane. Methoxy because the type of attachment that this mother chain has is single, thus methoxy. Ethane because there are two carbons present in this form, methoxyethane. Common name is methyl because the type of attachment we have in the mother chain, ethyl because there are two carbons. Next we have is the condensed form. In naming this, we must first identify our mother chain. Our mother chain is the one which has the most carbon. It is found on the right side. That leaves the left carbon, which is only one, the attachment, and it is dubbed meth because it's only one carbon. That is why we propose the name methoxypropane, methox, because there's only one attachment, and propane because there are three carbons in the mother chain. To get the common name, methyl because there's only one attachment, and propyl because there are three carbons in the mother chain. Carboxylic acids. This contains a carboxyl group, which is a carbon attached with a double bonded oxygen and a single bonded alcohol, then is connected with an R group. This can be found in vinegar, fats, and palm trees. For carboxylic acids, in naming this for our skeletal form, the IUPAC format is oct-5-enoic acid. We must first identify our mother chain, and this can be easily done because it is the only one which has carbons. The extension of carboxylic acids contain alcohol and oxygen. We name this oct because there are 8 carbons in the mother chain, 5 because the triple bond is found in the 5th carbon, ine because it is a triple bond, and oic acid for the prefix. There is a specific common name for carboxylic acids, thus this is named caprylic acid because there are 8 carbons. Now we have an expanded form for carboxylic acids, and the IUPAC name of this is 6-methylhepta-3-enoic acid. Take into consideration that COOH there is an extension to the carboxylic acids. First, we got our 6 there because there is an attachment found on the 6th carbon. And on the 6th carbon, the type of attachment we have there is meth because there's only one carbon. We got the 3 because on the 3rd carbon do we find our triple bond. And because it's a triple bond, we will name it ine. Altogether, we got our 6 because on the 6th carbon do we find our attachment, and the type of attachment we have is meth. We got our hepta because there is 7 carbons all in all in the form, 3 because on the 3rd carbon do we find our triple bond, ine because that is the prefix for the triple bond, ended with enoic acid. And for the common name, because there are 7 carbons, it is called enanthic acid. For this condensed form, the IUPAC name of this is pentanoic acid simply because there are 5 carbons and the prefix name for that is penta. For the common name, because there are 5 carbons, this will be called valeric acid. Esters. This compound is derived from the chemical reaction of carboxylic acids and alcohol with any organic group. This is found in flavors and fragrances. For esters, the IUPAC and common name is similar. The name of this skeletal form is butyl butanoate. We name this butyl simply because there are 4 carbons in the attachment and 4 carbons in our mother chain. We would know our mother chain simply because it is the one not affected by the ester group, which is a double bonded oxygen, a single bonded oxygen, and a single bonded carboxyl group or R group. For the expanded form, our name here is methyl ethanoate. We got our methyl because on our attachment, we only have 1 carbon, and for the mother chain, we have 2 carbons, which is ethanoate. Once again, to know our mother chain, it will be the one which has the most carbon or the one that is not affected by the ester group. For the condensed form, our IUPAC and common name is methyl butanoate. We got our methyl from our attachment, which can be found on the right side. You would know that this is an attachment because it is separated by the CO, which is the distinct factor in ester. It is a distinct feature of esters because this is the chemical structure of it. We got our butanoate from our mother chain, which is found on the left side. This includes the C coming from the chemical structure of ester.
And that is all. I am Sofia Brante, and thank you for listening to my crash course regarding ethers, carboxylic acids, and esters. Bye!